right, so today we are going to do still, it's infinite series. Okay, now we got the 9.8. 9.8, it is power series. So power series is the one actually you already been doing it. Remember Taylor series? That's a power series, right? McLaren series, that's a power series. Those are like a prime example of a power series. So power series is something that you just, like today I'll tell you this is a power series, but you've been using power series. You've been creating a power series. So those polynomial series that you created, those are the power series. So it's nothing new. You just have a name for it, but you've been doing it. It's nothing new. Okay, so objective for today is understand the definition of a power series, which you already know. Remember the polynomials you created using Taylor series or McLaren series, that's a power series. Okay, and the next one, find the radius and interval of a convergence of a power series. So when you create this polynomial, remember you said when I center at C, that area was really good. Like right by the C was really good. They're kind of like they're almost exactly same as elementary function that you want to find. But what happened? When you go farther, what happened? They're not a good estimate, right? You said this is not a good one. So in other words, there's a convergence. There's a convergence. So you know, like I say, up to -1 to 1, that's a good convergence. But after negative one or after +1, that's not that good. So you will see this radius of convergence. So you know, so we're gonna do that. Okay, and determine the endpoint convergence of a power series and differentiate the integrate power series. So we may not get to do all of them today, but this is what we're gonna do for the 9.8. All right, so this is another example. Look at this. So f of x equals e to the x. So e to the x is elementary function. So you can estimate e to the x by using a power series. Okay, so remember this, we already done this one from homework problem. So these are power series. Why is it power series? Look at each one of them. This is x to the 0 power, that's x to the 1 power, 2 power, 3 power. What happened? It's a power, isn't it? So that's what's called power series, just like what it is. All right, so, and then this is the definition. Okay, this is the definition of a power series. If x is a variable, then the infinite series of the form summation a sub n and x to the n is same as this, which is, this is what, same as what kind of thing is it? This is a Maclaurin polynomial because it's centered at 0. Okay, what is underneath? What is this one over here? That is what? Taylor's? That's a Taylor's polynomial, a center at C. So we already know this. We've been doing this. We've been using it in 9.7. We're just defining again formally. Okay, this is a definition of power series. All right, so next one. So this is a more example. We use, look at the 9.7. Remember all these elementary functions. Okay, 1 over x, 1 over 1 plus x, natural log of x, e to the x. These are elementary functions. Actually, you cannot solve exactly, what do you call it? Analytically, I guess. So a lot of time, what do? They do it numerically, okay? We can estimate this numerically. How do you do that? What do you do that? How do you do that? You use what? Power series, okay? You create a polynomials. You create these polynomials. That polynomial can estimate the elementary function. In fact, they're exactly the same. You see they're using an equal sign. So what they're saying is 1 over x, I can make it into what? This power series. Okay, and then this one is what? Looking at this, it's centered at what? 1, right? And looking at this, it's centered at 0. What is this one? It's centered where? 1, again, this is centered 0, centered 0, 0, 0, 0, and this is what centered where? K, right? So this is something that is very popular elementary function. Okay, I don't expect you to create every one of them, but you should recognize it. Especially sine and cosine in e to the x, they're very famous. They're extremely famous. You should recognize it. Just look at this and it's like, oh, okay, sine x is x minus x divided by 3 factorial. You know this is just sine. Look at this. Remember, sine does not have even function. Because why? Sine 0 is equal to what? 0. And here you don't see what? Cosine doesn't have odd functions, again, because sine 0 is what? 0. Okay. All right, this is the part that we're learning. So this is your new. This is your new. Okay. The power series in x can be viewed as a function of x. Okay, where the domain of f is a set of all x which the power series converges. Of course, every power series converges at its center. Of course, it will converge at the center because the center is the what we use to create our polynomial. So center is a trivial case. The center converges. But we need to try to figure out what? How far from center converges. That's what we're trying to study. Are you with me, class? The center is a trivial case. Remember this, you create the polynomial at where? At center. Of course, the center going to create, converges. Now let's look at it. Does everybody see why it converges? You replace x with the c, and c minus c give you 0. So of course you will converge to what? Very first element. There converges. So the first case, we don't even think about it because yes, you will converge. Of course you will converge because we create the polynomial at center C.
Where is this blackboard?
Yeah, it's in Blackboard. But I can also put this on the Blackboard. Even though it's not Jupyter Notebook, how about I put it into the Jupyter Notebook place so you can just look at it. All right, so radius and intervals. So you will see 3 different cases. The convergence. Only converge means there is a case that you create such a polynomial that only converges at the center. That's it. You just cannot create polynomial function that can match the elementary function that you want to create. That case, only one point. The center that you made, you're observing, that's the place, that's only place converges. Only place. What's another case? There's a second case, which is it will only converge what? Certain area. Remember all the polynomial that we created? What happened? It was only a good estimate about what? Maybe 1 point from this or 2 points from that. You understand that? Remember the pictures that you draw? That's this case. All right, you will find that R, the radius, we call it radius. The radius convergence of 1, that means you go from the center, you go to the left one, to the right one. Okay, what's the other case? The best case is what? You create your polynomial, what happens? Everywhere converges. That means you create the polynomial that exactly like the what? Elementary function that every place converges. You got a really good one. But it's not always true, right? You cannot have this kind of stuff always. But this is probably most common, let me say. This is probably most common. You will have some radius of convergence. But there's a case, every place will be converges. All right, now next one. So this is a formal definitions. The convergence of a power series. For power series center at C, precisely one of the following is true. Okay, this is the first graph, which is what? Only at C, right? Only 1 point. What's other case? There exists a real number R, which is a radius, okay? That's such that the series converges absolutely when? If x minus the center is less than R. what happens if that's bigger than R? Diverges. Okay, that's a formal definition. What's another one? So this is what definition. So you have a center and then you have what? Radius R. That's the second one, the second picture. What's the last one? It converges what? Everywhere. That's the third picture. Every place converges. All right, find the radius of convergence of this. N factorial times x to the n factorial. Okay, so this is what you have to do. Remember, you have learned different tests. Remember, you learn the ratio test, you learn what? Radical test, you learn alternative test, you learn different things. For this 9.8, almost every one of them, you're going to use ratio test. Are you with me, class? So I'm giving you already hint. So if you want to find your convergence, do the ratio test. Is everybody with me? Okay, let's do ratio test. So the very first one, this is the first case. What's the first case? We're going to just plug in trivial case, plug in x equal to 0. All right, plug in x equal to 0. Then you're gonna see, this is a very trivial case. Are you with me? The center, we're gonna see center is x equal to 0. So what happened here? Then you get 1 times everything else is what? 0, so you have a 1. All right, next one. For any fixed value of x, absolute value of x is greater than 0, we're gonna use this. All right, so we're going to do a second case. Remember, the trivial case is always true. So, but we're still gonna show it, okay? But now we need to see it. Do we have the radius convergence? Is only convergence C, or is it convergence needed more than that? That's what we're gonna find right now. Okay, everybody with me now? All right, so we're gonna do the ratio test. All right, so everybody with me? So we're gonna call this to be U sub n. Is everybody here? This is what you have to do on your exam. You're gonna say U is U sub n is equal to your given problem. That's your given problem. And then you're gonna write U sub n plus 1. Then this is your U, then what's U sub n plus 1? N plus 1 factorial. That's right, x to the n plus 1. Is everybody with me? Okay. Are you with me? Okay, just like what it says, it's U sub n plus 1. So I'm replacing all the n with what? N plus 1. Okay. Yes, you can write that down. So we're gonna do the ratio test. So you're gonna do U sub n plus 1 divided by U sub n. Does everybody see it? This is your U sub n plus 1. I'm gonna write down right here. And n factorial. Now, this is a time I want you to do linear algebra with me, because you need to cancel this one out. Okay, so we're gonna do the x first. So everybody agree this is the same as x to the this is x to the n plus 1 is what? Let me rewrite this one as well. X to the n times x to the 1 over x to the n. And then you said I'm gonna cancel this one out. Okay, what about the other one? N plus 1 factorial. Okay, n plus 1 factorial is the same as what? This means n plus 1 times what? N factorial, right? Are you with me, class? You take away 1 less, what do you get? N factorial. Yes, look at this. If you don't see it, let's look at this one. Okay, n plus 1 factorial really means n plus 1 times what? N times and what? N minus 1 times, N minus 2 times, N minus 3 times, dot, dot, dot. Am I right? Isn't that what that means?
Not factorial.
Factorial means 3 factorial means what? 3 times 2 times 1, 1 less each time. Are you following me, class? Example, what is 4 factorial means? 4 times 3 times 2 times what? 1. What happened? 1 less each time. Do you see a class? All right, so what's n factorial means? N times n minus 1 times n minus 2 times dot dot dot. Are you with me, class? So everything will cancel out, cancel out, cancel out, cancel out, cancel out. Only thing left with which one? N plus 1. Is everybody with me? Okay, so I can say, okay, only thing left with, so I only have n plus 1 left. So n plus 1 factorial divided by n factorial left with which one? N plus 1 only. Okay, everybody with me? Okay, this is a simple thing. So you only have n plus 1. Now, class, I want you to leave, bring out the x in the front. Remember, we're taking the limit, n goes to infinity, right? N goes to infinity, not x. So x does not matter what the n does. So bring out the x in the front of the limit, because x does not matter when n goes to infinity. Now, the ones you don't need it, but it does not affect it by, remember, look at your limit. Limit is what? N goes to infinity. It doesn't say x goes to infinity. X does not affect it by how n goes to. Okay, are you with me? So now that's what it is. Now look at this. Then what happens? When you plug it in, n is infinity, what happened then? Infinity plus 1, which is what? Infinity, isn't it? So your answer is x, the entire thing become a what? Infinity. Okay, so what can you say? Therefore, the ratio test, the series converges for x. Okay, absolute bar x is what, greater than 0? What happened? Diverges. Only place it converges what? At center.
Okay, so we did a ratio.
Yes, this is your problem. This, what did you just find out? It only converges where? X equal to 0, which is the center. And then what happened to other places? Diverges. It diverges everywhere, except the where at the center. Which makes sense. Look at this problem. It's n factorial. Okay. So you plug it in, and as an infinity, of course you're gonna go to infinity.